Ozempic and drugs like it are powerful, versatile, and have made a huge difference in some people's lives. Semaglutide, the active ingredient in Ozempic, is FDA approved for managing type 2 diabetes, chronic kidney disease, and yes, weight loss. That last one is by far the biggest, leading to massive commercial success and celebrity endorsements everywhere you look. And thanks to that popularity, dozens of drugs are in the pipeline looking to capitalize or even improve that formula. So let's take a look at how they work in order to understand what the science says about the potential sequels to Ozempic. Could they be new and improved, or an unwelcome remake? Now, we don't necessarily endorse weight loss for its own sake. You should talk to your doctor about it as part of your personal overall health goals. Our social stigmas on weight aren't something a drug can fix. That's something the human condition needs to work on. What we can't deny, though, is that these are some seriously powerful drugs that are the results of some serious science. Ozempic first earned FDA approval back in 2017 to help manage type 2 diabetes and related complications. The primary problem in type 2 diabetes is hyperglycemia, which is when your blood sugar levels are too high. Usually when your blood sugar creeps up too high, your pancreas makes insulin, which tells your cells to gobble up some of the glucose in your blood, bringing it back down to normal levels. In type 2 diabetes, or T2D for short, the pancreas either can't make enough insulin or your cells don't do what they're told when the insulin is there, which leaves the glucose in your bloodstream. Managing blood sugar levels is super important in T2D, especially since hyperglycemia is linked to heart disease and stroke, which is where Ozempic comes in. You've probably heard the term GLP-1 thrown around a lot in the media when it comes to Ozempic. GLP-1 stands for glucagon-like peptide 1, and it's a naturally occurring hormone in the body. Most of it is made by cells in your intestines in response to a meal. Then its big job is traveling to the pancreas and binding to GLP-1 receptors, which tell the pancreas to release insulin, which then helps the cells in your body pull the sugar from your blood and lower your blood sugar. Semaglutide, the active ingredient in Ozempic, is a GLP-1 receptor agonist, or GLP-1RA, meaning it's a mimic that binds to the same receptor as GLP-1 and activates it to do all the same things. The receptor basically says, close enough, and proceeds with releasing insulin from the pancreas. So that's why semaglutide works great for type 2 diabetes, and by extension, helps reduce cardiovascular events. But recently, its claim to fame is as a weight loss drug, because those little receptors aren't exclusive to the pancreas. Back in your gut, activated receptors can slow stomach emptying, which means you feel full for longer, and you're less likely to snack if you feel full. You also have GLP-1 receptors in your brain, and researchers think that semaglutide interacting with those can dampen the sensation of hunger and reduce food cravings. Technically, for weight loss, semaglutide swaps its marketing name tag from Ozempic to Wegovy. Same stuff, just under a different label with different dosing. Semaglutide isn't the only GLP-1RA on the markets that can help with weight loss, though. There's a bunch of them, mostly with long, unpronounceable names ending in tide. One of the newest is orforglipron, which was approved as recently as April 2026. By the way, who comes up with these names? I feel like they're watching this video now just waiting for me to trip up, which I'm not going to. I practiced. They're all different formulations, and that last one's actually a pill instead of an injection, but they all can bind to those GLP-1 receptors. But GLP-1RAs aren't the only form these weight loss drugs can take. Zepbound, with its active ingredient tirzepatide, is both a GLP-1RA and a GIP-RA. Since a GLP-RA was a mimic of GLP-1, that makes GIP-RAs a mimic of GIP. But what's this new acronym, GIP? Well, it's a different hormone that stimulates insulin release in response to meals and helps to manage hunger cues in the brain. So tirzepatide is a 1-2 punch against hyperglycemia and cravings, activating both GLP and GIP receptors. Right now, it's the only FDA-approved dual receptor agonist, but many drug companies are looking to change that. So let's talk weight loss drugs currently in clinical trials. One such drug is called CagriSema. It's half semaglutide, the active ingredient in Ozempic, and half cagrilintide. Since weight loss drugs are all about pretending to be human hormones, this one mimics the hormone amylin, which can slow stomach emptying and help make people feel satiated. That means CagriSema uses the original GLP-1 path and this other amylin pathway to help someone lose weight. In clinical trials, this combo had strong results, with the duo drug working better than either semaglutide or cagrilintide alone. Patients taking CagriSema dropped an average of 20% of their body weight, whereas semaglutide was around 15% and cagrilintide was around 11%. And a follow-up trial was able to replicate this weight loss success in patients with type 2 diabetes. Plus, the drug showed significant reductions in hemoglobin A1C levels, a key indicator of blood sugar levels, over the last few months. The last of the phase 3 trials are estimated to end in late 2026, and the drug company has already applied for approval. But why inject two individual drugs when biochemists can smash them together into one? Enter amycretin, a peptide designed to bind to both GLP-1 and amylin receptors. It does the same thing as CagriSema, but as a single molecule, so it's a little more convenient. And unsurprisingly, people still lost a significant amount of weight, with some dropping up to 24% of their baseline body weight. That drug began phase 3 clinical trials in 2026, both as an obesity drug and as another option for controlling type 2 diabetes, because a phase 2 trial showed almost 90% of patients reached acceptable A1C levels. It's likely that some version of this semaglutide and amylin hybrid will be approved in the next few years. And there are other 2-target combos being worked on too. There's even some 3-target drugs in development. For example, Retatrutide. This drug is able to bind GLP-1 and GIP receptors similar to tirzepatide, aka Zepbound. But then it also can bind glucagon receptors. Glucagon is a hormone in the body that kind of counteracts insulin. Where insulin works to get sugar out of the bloodstream and into storage, glucagon works to pull glucose out of the storage and then into the bloodstream. So while insulin helps prevent hyperglycemia, glucagon helps prevent hypoglycemia. Kind of sounds like the opposite of what a weight loss drug should do, but the physiology behind these hormones is rarely that straightforward. In addition to increasing blood sugar, glucagon increases insulin secretion, which is something that should help counteract that increased blood sugar. Studies also suggest that glucagon decreases appetite and slows stomach emptying, with some researchers hypothesizing that this happens due to cross-reactivity with GLP-1 receptors. So there is evidence that it could help with weight loss and blood sugar management. But Retatrutide doesn't just bind those 3 receptors as if it were the natural hormones. It binds the GIP receptor way stronger than the natural stuff, while the GLP-1 and glucagon receptors get weaker binding. So in addition to doing the job of 3 different hormones, it also customizes how much each receptor is stimulated, something the natural stuff just can't do. And stronger isn't always better, especially in pharmacology. Being able to dial in stronger and weaker binding to different receptors can have a big impact on drug efficacy and safety. So far, the balance this drug strikes seems to work pretty well. Early phase 1 trials showed that it was safe and could help decrease weight and A1C levels. At the highest dose in phase 2 trials, participants saw an average of a 24% decrease in body weight after a year of use. And while it will still be several years before all of the phase 3 trials for the drug wrap up, some of the published results already report almost 30% body weight losses and significant improvements in A1C levels. Plus, this drug is being investigated for other uses too, like reducing cardiovascular events and managing chronic kidney disease. So it's not just the massive weight loss market that these drug developers are trying to court. But one problem with pretty much all of these drugs is the side effects, which pretty consistently include nausea or some other type of stomach upset. And although some versions, like tirzepatide, try to minimize those side effects, the only real way to deal with them has been starting with low doses and slowly increasing. Plus, stomach upset isn't the only risk with these drugs. Other, more severe side effects that can come up include kidney damage, pancreatitis, and thyroid cancer. Other problems are being worked out too. One phase 2 clinical trial combined semaglutide and a drug called bimagrumab in an attempt to focus body weight loss on fat while preserving muscle weight. That combination was successful in making large reductions in body weight, and adding bimagrumab to semaglutide resulted in about 20% less muscle loss than semaglutide alone. But all of these drugs are kind of variations on the same glucagon and glucagon-like pathways, which is fine. They're definitely the most trendy targets right now, but they aren't the only ones. A different option is the cannabinoid receptor. You might be familiar with the term the munchies, which describes the increase in cravings and appetite associated with cannabis use. Both consumers of cannabis and scientists agree that there is a strong relationship between cannabinoid receptors and hunger. And because of that relationship, those receptors are an attractive target for controlling hunger and losing weight. Progress on drugs targeting this receptor has been slow, partially because regulatory bodies generally frown upon a weight loss drug whose side effect is gets you high. Okay, that's not the literal problem, but messing with your reward pathway seems problematic. So it took drug makers some time to figure out how to utilize this receptor for weight loss without inducing a high or affecting your reward pathways. Those kinds of drugs are in the super early stages, but they all aim to inhibit the receptors and suppress hunger. Only one such drug, called monlunabant, has completed 2 phase 2 clinical trials so far. But it isn't super promising because at the highest dosage, over 90% of participants saw adverse effects, including psychiatric side effects. Although it's worth noting that a weirdly high amount of people in the placebo group saw adverse side effects as well. Still, in the high dose scenario, over 40% of participants withdrew because of the side effects, which means a cannabinoid receptor-based approach to weight loss might still be a ways off. These drugs aren't the sequel to Ozempic, but maybe they'll make the threequel? Neuropeptide Y2 receptor agonists are also being investigated for weight loss, though they are similarly early and troubled. One phase 1 clinical trial was hoping to alleviate some of the GI issues by using a neuropeptide Y2 receptor agonist with a GLP-1. And while it found some additive effects for weight loss, the GI issues still persisted. Another study in mice found that the drug could enhance the efficacy of a dual glucagon and GLP-1 receptor agonist, but didn't induce significant weight loss when taken alone. These studies are only from the last few years, so it may just be that drug companies need more time to tweak it before it's successful in clinical trials. In fact, a lot of these drugs, whether GLP-1 based or not, need more research before they can reach these Ozempic levels of fame. There is a lot of active research going on behind all the headlines you hear, but one thing is clear: drug companies and patients alike have a real appetite for some kind of sequel to Ozempic.